Let's take a look at this problem. We got f of x is equal to x to the fourth plus 5x to the third plus 6x squared. Now, first thing we're going to find is the domain. Since it's a polynomial, your domain is negative infinity to positive infinity. Second thing we'll find is the x-intercepts. You always plug 0 into the other variable. So if I find the x-intercepts, I plug 0 in for y. So I got 0 is equal to x to the fourth plus 5x to the third plus 6x squared. Now we want to solve this. Well, we can factor out a GCF first. I notice they all have an x squared. So we've got x squared, factor that out, and that gives us x squared plus 5x plus 6. We then can factor using the PST method, because we've got x squared, no number in front of our x squared. So we're going to have x squared, and then x plus 2 times x plus 3. Zero factor property says if you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'm going to set the x equal to 0, and I'll set x plus 2 equal to 0, and I'll set x plus 3 equals 0. So we've got x equals 0, x is equal to negative 2, and x is equal to negative 3. Now, one thing to notice on this particular problem, we have the second power on the x. That means it has a multiplicity of 2, which means that this one specifically touches at a point where the other ones are going to cross. Remember, when finding our intercepts, our x-intercepts, it's the same as finding zeros. C. We want to find the, we just found the x-intercepts, we want to find the y-intercept. You always plug 0 into the other variable, so f of x is y equals 0 to the fourth plus 5 times 0 to the third plus 6 times 0 squared. And that gives us 0. And that's our y-intercept. And these are our x-intercepts. Okay. D. Vertical asymptote. E. Horizontal asymptote. F. Slant asymptote. None in all of these. You have to have a rational function to have those. G is probably increasing. Yeah. So I need to find the derivative. Our first derivative, x to the fourth, becomes 4x to the third. Plus 5 times x to the third becomes 3x squared. Plus 6 times x squared becomes 2x. So that gives us 4x to the third plus 15x squared plus 12x. Now I want to find our critical value, so we'll set that equal to 0. So I got 4x to the third plus 15x squared plus 12x equal to 0. First thing I notice is I can factor out a GCF. They all have an x in common. And that gives us 4x squared plus 15x plus 12 is equal to 0. Trying to see if it factors. I'm not seeing it. Doesn't mean they can't. If it does factor, it'll be key number. Because we have an x squared, no x, and there's a number in front of our x squared. Key number, we take a number at the beginning times a number at the end. So I got 4 times 12, which gives us 48. We'll come up with our 3 columns. We got 1 times 48. P is all the products give us 48. 2 times 24, 3 times 16, 4 times 12, 5, no, 6 times 8. Add these, that's the S column. 1 plus 48 is 49, 2 plus 24 is 26, 3 plus 16 is 19, 4 plus 12 is 16, 6 plus 8 is 14. Subtract them. 48 minus 1 is 47, 24 minus 2 is 22, 16 minus 3 is 13. 12 minus 4 is 8. And 8 minus 6 is 2. Number we're looking for is the number in our middle term, which is 15, which we don't have anywhere. Well, let's plug this in. Well, that's as much as we can factor. So we set each factor equal to 0. So we got x equals 0, and we got 4x squared plus 15x plus 12 equal to 0. Now I could use the quadratic formula on this, but it's a lot easier to use a calculator. So I'm going to come over here. I'm going to press y equals, clear. Then I got 4x squared plus 15x plus 12 and 0 on y2. So now do second trace, choose intersect, and I have no clue. Let me do inner on first curve, inner on second curve, put in -3. We're inputting an x value close to where we think the answer is. Looks like -2.6 is what it rounds to. So we got x is equal to 0, x is equal to -2.6, and one more. That one looks like -1 actually. So second trace, choose intersect, inner on first curve, inner on second curve, let me put in -1. It's close. -1.2. So x is equal to -1.2. Now those are critical values. So we want to build a table of intervals based upon that. So I'll put smallest one over clear to the left, which would be -2.6. Next one is -1.2. And I'll eventually get it here. One more time. -1.2, and then x equals 0. I'm going to choose test cases. Something between, this is negative infinity over here. This is positive infinity. Something between negative infinity and -2.6, like x equals -4. Something between -2.6 and -1.2, like -1.5. Something between -1.2 and 0, like x is equal to -1. And something greater than 0, like 1. Now we want to plug those into our derivative and see what we get. Now our derivative is right here, so let's go enter that into the calculator. Make our life a little bit easier. No, I don't have it there. Okay, so I'm going to do, I did y equals clear, and then we got 4x to the third. There we go. Plus 15x squared. Plus 12x. Now let's make sure our table's set up correctly. So I'll go into second window for table setup, and you should have independent saying ask. If it doesn't say ask, down arrow to that line, right arrow, and press enter on ask, and it'll select it. Now if we do second graph, go in table mode. I have a few numbers from previous problem, and clean those out. We want to plug in our test cases. So we got -4, enter, -1.5, enter, -1, enter, 1, enter. Okay. -4 gave us a -64, which means this is decreasing. -1.5 gave us a positive 2.25, so this is increasing. -1 gave us -1, which is negative, so it's decreasing. 1 gave us 31, which is positive, so it's increasing. So this is decreasing from negative infinity to -2.6, and then it's increasing from -2.6 to -1.2, and then it's decreasing from -1.2 to 0, and then it's increasing from 0 to positive infinity. And what was that? That was G. So H, min and max. Well, our min and max occur when the graph changes from increasing to decreasing, or vice versa, assuming the point exists. So this one's decreasing and then changes to increasing, so this is going to be a min. Up here it's increasing, changes to decreasing, so this is going to be a max. And here it's decreasing, changes to increasing, so this is going to be a min. So we're going to have a min at negative 2.6 comma something. We'll have a max at negative 1.2 comma something. And then we'll have a min at 0 comma something. Now we want to plug those back into our original function. This one right here. So let me go back to y equals. Press clear. And I got x to the 4, so x caret 4 plus 5x to the third plus 6x squared. Our calculator is already set up for a table, so I'll do second graph to go into the table. Press delete a few times to clean out those old ones. And we got negative 2.6. We got negative 1.2. And we got 0. Okay, so this one, negative 2.6, will give us negative 1.6. I'll round it to one decimal place. For purposes of graphing, doesn't do much good to go beyond that. Negative 1.2 gives us 2.1. And 0 gives us 0. So this will be our min and max, and these are increasing and decreasing. I. We're ready for our concavity. So I need to find our second derivative. Well, let's go up. Our first derivative is this right here, 4x to the third. Let me write this down on a piece of paper so I don't have to keep scrolling up. So 4x to the third plus 15x squared plus 12x. Okay. Let me clean that out. There we go. So let me write that down. Our first derivative was 4x to the third plus 15x squared plus 12x. So then we'll take the derivative of it. That'll give us our second derivative, which gives us 12x squared plus 30x plus 12. Now we want to set that equal to 0 so we can find our critical values. So we got 12x squared plus 30x plus 12 equal to 0. First thing we'll do is factor out the GCF. They're all divisible by 6. So that comes out, and that gives us 2x squared plus 5x plus 2 equal to 0. And I think that factors. If it does, it'll factor with key number. Let's see. 6, and then we got 2x, then x, and then 2. 1 plus. Let's see what that gives us. 2x times x is 2x squared. 2x times 2 is 4x. 1 times x is 1x. So 4x plus 1x is 5x. And 1 times 2 is 2. Okay, that works. Zero factor property. It says if you get 0 on one side and you factor the other side, set each factor equal to 0. So I got 2x plus 1 is equal to 0, and x plus 2 is equal to 0. Which gives us 2x is equal to negative 1, or x is equal to negative 1/2. And this one takes 2 over, and we get x equals negative 2. I want to build our table of intervals. So negative 2 is our smallest one, and then negative 1/2 is here. Clear over here is negative infinity, clear over here is positive infinity. Want to choose test cases, something between negative infinity and negative 2, like negative 3. Something between negative 2 and negative 1/2, like negative 1. and something greater than negative 1/2, like 0. Now we want to plug those into our second derivative. And factored form is perfectly fine to plug it in. Like you can do that right here. That way I don't have to go use my calculator. 6 is always positive, so I don't have to worry about it. But if I plug in negative 3 for the x, 2 times negative 3 is negative 6 plus 1. That gives us a negative number. If I plug in negative 3 here, negative 3 plus 2 gives us a negative number. Negative times a negative is positive, which means this is concave up. Now if I plug in negative 1, 2 times negative 1 is negative 2 plus 1 is negative 1, so that's negative. And if I put in negative 1 here, negative 1 plus 2 is positive 1, which is positive. Negative times positive is negative, so this is concave down. And if I put 0 here, 2 times 0 is 0 plus 1, that's positive. If I put 0 here, 0 plus 2 is positive. Positive times positive is positive, so it's concave up. So for concavity, this will be concave up from negative infinity to negative 2. Then concave down from negative 2 to negative 1/2. And then concave up from negative 1/2 to positive infinity. Okay, now our POI is where the concavity changes, assuming the point exists. This is concave up, then changes concave down, so we have a POI at x equals negative 2. And it also changes here, so we have a POI at x equals negative 1/2. So our POIs, we're going to have one that's negative 2 comma something, and the other one is negative 1/2 comma something. Now we want to plug those back into our original function, which is this right here. So let's enter that in if it's not already entered. So press y equals x to the 4th plus 5x to the 3rd plus 6x squared. It's already in there. So I go to my second graph, go in table, press delete to clear out those old ones. And we want to put in negative 2 and negative 1/2. So negative 2, enter, and negative 1 divided by 2, negative 1/2, enter. Okay, our first one gives us negative 2, 0. This one's negative 1/2, 0.9. And those would be our POIs. I don't hardly have room to sketch it. Let's just graph it on the calculator and verify that the graph is correct. So we've already put that in there under y equals, so I just press graph. It's hard to get the x-intercepts wrong since we use the actually we didn't use the intersect method then that time. Never mind. 0, negative 2, negative 3. 0, negative 2, negative 3. That seems reasonable. Y-intercept is 0. Yeah, that also seems reasonable. Increasing, decreasing, so forth. This says it's decreasing to negative 2.6. So it's decreasing, negative 2.6. Yeah, that seems about right. Then it's increasing from negative 2.6 to negative 1.2. Yeah, that looks about right. And then it's decreasing from negative 1.2 to 0, and then it's increasing. Yeah, our graph looks accurate, what we're seeing on the screen. Our min is negative 2.6 and negative 1.6. Negative 2.6, negative 1.6. That looks like a min. Max is negative 1.2, 2.1. Negative 1.2, 2.1. Yeah, that looks like a max. And min is 0, 0. Yeah, that sure looks like it there. Concavity you can't really see real well in a lot of problems, so I'm not even going to look at that. But this is looks like a fairly accurate sketch. So you just sketch this down and that would be your graph.